This video is for the Unit 1 Skill 4 formative key on the chain rule. As we saw in class, the chain rule is really important and it stems from our understanding of compositions of functions. So one of the first things I want to identify when I'm looking at problems that involve the chain rule is how many functions am I dealing with? So if I look at a problem like the one at the level 2, I have R of t describes what it models, snow blown at a local ski resort, etc. It ultimately wants me to determine what the derivative is equal to. So when I look at R of t, here's what I see. I see three functions. I see sine of x, I see x cubed, and I see 4x, or in this case t, plus 1. So that means that I should ultimately be taking three derivatives that I will end up multiplying together. Next, the second thing that's important is that I need to identify the compositions, and those compositions carry through. So if I were to read R of t, I would read it as the sine of 4t plus 1, that quantity cubed. So when I take each respective derivative, I'm going to carry the compositions through. So the outermost function in this case is x cubed. I'm going to take the derivative of the outermost function first. The derivative of x cubed is 3x squared. But I want to remember that x squared is the composition here. That can be a little confusing. So I'm going to have 3 x squared. And hopefully by me pausing there, I help to explain exactly what I was doing. The derivative of x cubed, or in this case, sine of 4t plus 1 quantity cubed, is a power rule. I reduce the power by 1 and bring the 3 in front, but the composition still carries through. My next function is sine of x. The derivative of sine of x, as I learned, is cosine of x. But my x in this case is 4t plus 1. Again, carrying through that composition there. And finally, I have the function 4x plus 1, or 4t plus 1, which has a derivative of 4. In the AP setting, they would show the answer like this. 12 sine squared 4t plus 1 cosine 4t plus 1. Also, the three-function composition is the most common question that they ask when given in the multiple choice setting via the chain rule. Okay, next, level 3. Well, level 3, once again, we see the symbolic representation. We have a function h of x, which is composed with tangent of x. So again, I see c of x as two functions, h of x and tangent of x. So I want to find the tangent line, which has been the consistent level 3 question throughout these last 2 weeks. So tangent line, again I'm thinking y minus y sub 1 equals m times x minus x sub 1. I'm told in this particular problem that x is equal to pi. So I've got my x coordinate. So now I will need my slope and I will need my y coordinate. I can get my slope by taking my derivative via the chain rule. So c prime of x equals the derivative of h, which is h prime symbolically. And some kids actually find that they prefer chain rule problems symbolically versus the functions. You'll decide what kind of kid you are, but that's been something that's been noted in the past. And then, of course, the derivative of tangent is secant squared. I want to evaluate this at pi. The tangent of pi is 0. The cosine of pi is negative 1. The reciprocal of negative 1 is negative 1. And negative 1 squared is positive 1. H prime of 0 I get from above. 3 pi over 2 times 1. Therein lies my answer. Last thing I need a y-coordinate still. So c of pi. Well, that's going to become h of the tangent of pi. Tangent of pi is 0. H of 0 equals pi over 3. My final answer then for this question, y minus the y-coordinate equals the slope times x minus the x-coordinate there. And that is a pi at the end. Finally, we'll move to the level 4 here. We see in this case, again, a more difficult application of the chain rule represented through a symbolic lens. Okay, here we go. So I want that derivative when x equals 2. I have a table of lots of values, and I have plenty of compositions. I have two functions here, f of x and g of x. And I have three functions here, g of x, f of x, and 2x. So let me go ahead and start taking derivatives here. So I have f of g of x, so that will become f prime of g of x, still carrying that composition, times g prime of x, plus, and now I have three functions, so I'll take three derivatives and carry those compositions through. G prime of f of 2x times f prime of 2x, and then the derivative 2x, which is 2. So you should pause the video now if you have any uncertainty about where all that came from to make sure you're clear before we move on. Now we're going to start evaluating this at 2. So I'm going to replace all the x's with 2. Of course, that became a 4 because it was 2x, and 2 times 2 is 4. Okay, g of 2. G of 2 is negative 2, and f prime of negative 2 is 4. G prime of 2 is 0. Oh, that's going to be nice. F of 4 is negative 2. G prime of negative 2 is negative 2. F prime of 4 is 5 times 2. And now this all cleans up very nicely to a final answer of negative 20.